Okay, so good morning everyone. So I think I can start the class now. Remember that you will have the assignment due today is handing homework 4. Okay, that's the handbook you should submit to me today. Okay, it's better to sit here to see all the things on the board and screen. If you sit down there, you will maybe miss something when I run the board. Okay. Okay, so you will have the second exam on this Friday, and remember that all the things I will review today and next Wednesday are very similar to the second exams. Okay, so if you miss the day, okay, please let your friends watch my videos on Canvas. Okay, so maybe it's very helpful for them to do the exams. Okay, now we will review the chapter 4 and 5, 6. Okay, the first thing I want to recall you is classical probability. How to call it? How to calculate the classical probability? Okay, we suppose that I have the event E. Okay, I have the event E. Okay, and the probabilities of E, okay, is calculated by the number of the possible result in the event E and the number of the possible outcome. Okay, number of possible result in the sample space. So here is the number of possible result in event E, and here is the number of possible result in the sample space. Okay, so that is the classical probability that you study in the chapter 4. And we also have the experimental probability. Okay, for example, I have the experiment E, and in this case, the experiment, we have experimental probability. We have two kinds of probability that we can calculate. We also have subjective probability, but we don't care about this because the subjective probabilities depends on the pupil or something related to this field. For example, we can guess the weather today, something like this. Probability have raining today, something like this. We cannot do that, right? That depends. That depends. So we don't care about the subjective probabilities. We also focus on classical probabilities and experimental probabilities. Regarding the experimental probability, so it will be calculated by this formula where F here is the frequency, and here is the number of times we do the experiment. Okay, that is the thing. Okay, so now I will give you some example for this. So in this sample exam, so you will see some kind of problem like this. Okay, for example, you look at the problem 1. Okay, maybe you will have the sample exam in your hand. Okay, a standard 6-sided die roll, and the question is, what is the probabilities of running a number greater than or equal to 3? Okay, express your answer as simplified fraction or decimal rounded to 4 decimal places. Okay, here when you look at this kind of problem, so you have two answers for this. First one for this is a simplified fraction. Remember, it's simplified fraction. If you don't want to write in the simplified fraction, you need to round it to 4 decimal places. Okay, I will give you. Okay, it's finished. Okay, now we look at the problem 1. Problem 1. So we have the event here is. Okay, we have the event E is here is rolling dice, right? Rolling a die and a number that is greater than or equal 3. Okay, that's either event E. Okay, so now the question here asks us to calculate the probability of E, right? The probability of this event. Okay, so could you tell me how many number of results, the number of possible results in this event E? Okay, how many? Look at the event E. Could you tell me okay, how many possible results in this example? Okay, Robin, please. Okay, another answer for this? Okay, Maria?
Would be 3.
Okay, 3. Why you choose 3?
Would be 1, 2, and 3.
That's it greater than or 3? Greater than or equal 3. Okay, so, okay, Robin again.
4.
Okay, 4. So this is 3, 4, 5, 6, right? Okay, because the possible result of the die is 1, 2, 3, 4, 5, 6. But the answer here is the experiment here is the number that is greater than or equal 3. So we will choose 3, 4, 5, 6, right? Okay, so that's the 4 possible results. Okay, 4 of you got the point of this. Okay, so the possible result is 4, right? The number of possible result in the sample space here is 1, 2, 3, 4, 5, 6. So we have 6, right? Okay, so this is over 6. Okay, this is clear, right? And here is 4 over 6. This means that this is 2 over 4, 2 over 3. Okay, this simplify result. You can submit this result, or you can submit right 0.6667. Okay, two answer here are accepted. Okay, you can write the answer like this, or you can write an answer like this in your exams. Okay. Any questions so far about this? Okay, that's the question 1. So in this exam they will be have the problem like this. Okay, similar like this. Maybe change the number. A box contains 26 red marbles, 96 white marbles, and 6 blue marbles. And I will choose randomly the marble. Oh, let me see. Okay, and I choose randomly the marble from the box. Okay, and the question here is, what is the probability that it is red? Okay, so now I will go to the problem 2. Okay, could you tell me what is the probability in this case? Okay, we have the information like the 36 red bubbles, 96 white bubbles, 6 blue bubbles, and I choose one of them. Okay, and probability, I guess, red bubble is. Would you tell me? Okay, Mackenzie, please.
26 over 128.
Yeah, exactly. Thank you, Mackenzie. How do you get that?
When you add up 26, 96, and 6, you get 128. So it's like the total possibilities, and then there's 26 red ones.
Okay, thank you. That's a good answer. Okay, the first one we have the total marble here is 26 plus 96 plus 6, right? Okay. And after that you will calculate the probability. Okay, because we want to calculate the probability we get red, right? Okay, so we only have 26 red, right? So we need to over to this value. So that is the problem, because we have only 26 red marbles, and here is the total marbles. So the probability is 26 over the total marbles, the number of marbles. Okay. Okay. So now you need to simplify this. Okay, with 26 over this number. So this is this value. You can write like this, or you can write like this. Okay. For decimal places. Okay, look at this big keyword for decimal places. Okay, so now we have to go to the problem 3. Okay, so write out the sample space for the given experiment. Use the letter H to indicate heads and T for the tails. And we have the experiment is 2 coins are tossed. Okay, I have the coins like that, and I toss twice, right? Okay, in this question, we should use the 3D diagram to do this. You should use diagram to do this. Okay. We have 2 stages, right? We have 2 stages. The stage 1 and stage 2. In stage 1, okay, 2 coins are tossed, so I will have 2 possible results, right? Not possible result F, T, right? And after that, the second one will be H or T, and the second one will be H or T. So after that, I will write all the possible result here: HH, HT, TH, TT. Okay. When you toss 2 coins, maybe you will get 2 heads, 1 head, 1 tail, 1 tail, 1 head, or 2 tails, okay, something like that. You don't need to write like in this question. You don't need to use 3 diagram. That's fine. But in problem 4, if you don't use the 3 diagram, maybe you will miss some cases when you list all the possible outcomes. Okay. In this case, we write down like this: X, 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 T, T, X, T, T. That's all the possible result of this experiment. Okay. Any questions so far about this? Okay. And now we will move on to the next examples. Next questions. Okay. So the question here is write out the sample space for the given experiment. Okay. I will use O for olive, S for spring, T for turkey, F for French, H for honey, something. Okay, so now when deciding what you want to put into salad for dinner at restaurant, you will choose one of 2 following extra toppings. Okay, olive or this guy, and after that we will choose one of the following meats: shrimp, turkey, and lastly we will choose the French or honey. Okay. So the question here is write all the possible results of this experiment. Okay. So in this experiment we have 3 stages, right? We have 3 stages. First one, we will choose the toppings, right? The second one we will choose the meat, and the last one we will choose dressing. Right? We have 3 stages. 3 stages. And in this case, it is better to use the 3 diagram. Okay, we have 3 stages: stage 1, stage 2, stage 3. The stage 1 we will choose the topping. Stage 2 we will choose meat, right? And the last one we will choose the dressing. Okay. What is possible result in stage 1? So we have two cases, right? Olive and this one. Okay, so we have O here and A here. Is it clear? This one. What about stage 2? So in stage 2 we have to write down here. What is possible result in stage 2? Okay, you please.
Shrimp and turkey.
What's your name, please?
Caitlin Kip.
Caitlin.
Yes.
Okay, exactly. Thank you. So that is the shrimp and turkey. So we write down shrimp and turkey here. right? And the last one, what is the possible result in stage 3? Okay, lead please.
SH.
Okay, F, the last one. The last one we choose the resting.
Wait, for number 4, right?
Okay, that is the last
French
one.
Indian honey mustard.
Yeah, exactly. French and honey. Okay, so now we finished the G diagram here, but now we will list all the possible results. Okay, for example, OSF, okay, right on the line. OSF and OSF, OSH and OTF, OTH and ASF, ASH, ATF and ATH. Okay, so that's one represent for the first one you choose olive, okay, and the second one we choose for Turkey, and F here choose for French, something like this. Okay, so that is the sample spaces. Okay, any questions so far about this? Okay, let me know if you have any trouble for this. Okay. Okay. So now we will move on to the experimental probabilities in the you will see the kind of probability in question 5. Okay, you decide to record and have colors of people living the lectures at your school. What is the probability that the next person who leaves the lectures will have brown hair? Will have brown hair. Okay, so I will. Okay, we'll have brown hair. So express your answers as simplified fraction or the decimal product to 4 decimal places. Okay. So look at here. Okay, so now look at the question 5, and the question here is probability that the next person who leaves the lecture will have brown hair. Okay, so here we have the experimental probability, so that we will use the probability here is equal to F and N. F here is a frequency and N is a number of the time we do the experiment. Okay, could you tell me what is the probability in this case? Taylor, right? Or okay, Xavier, right? Xavier, okay. Xavier, sorry, Xavier. Okay, you say it again.
34 over 171.
Okay, 34. 34. Okay, so how to get this? Okay, 34, right? Okay, 34. The number here, you first order the number here, right? Okay, so it's 45 plus 21 plus 34 plus 17 plus this number. Okay. Because we have the total student here, right? This is the total student, and this is the student having brown hair. Okay. So now we will get the result here. Okay. The denominators should be this guy. Okay. So you can, it's not signified, so you can keep this, or you can write in the number like this. Both of the answer here are accepted, right? Any questions so far about this? That's the experimental probability. Okay, and now we will move on to the problem 6. Okay, that will be harder than these kind of problems. A box contains 14 large marbles and 11 small marbles. And each marble is either green or white. 7 of the large marbles are green and 3 of small marbles are white. Okay. So to choose randomly. And the question here is what the probability that it is more or green. So now I will give you some review something about the probability of this kind of problems. Okay. I will write down. So we have the additional rule. For probability. Okay, the keyword here is what is the probability that it is more or green? All here, right? Okay. So we have two events. E and F. So the probabilities of the event E or F. Okay. Okay, do you remember this formula? What is probability of the event E or F? Do you remember this formula?
Probability of small and green.
No, I just asked you this question. It's don't care about the problem letters. I just asked you the formula for this. Literally.
Is it P of E plus P of S minus P of E and F?
Yeah, exactly. Thank you. Okay. So the probability of E or F is probability of E plus probability of F minus the probability of E and F. Okay, this formula is very useful in this case. Okay. So now we will look at the problem like this. Okay. So E here is okay. The event here is okay. We go to the problem 6. We need to calculate the probabilities. The marble is small or green, small or green, right? We need to calculate this, right? And the probability of small or green is probability of small. Okay, we get the small marbles, and probability we get the green marbles minus the probability that we will get the small and green marbles. Is it clear? What you need to do? Okay. And now we will look at the problem. So could you tell me how many small marbles in this case? 11. 11 small marbles? Okay, exactly 11 small marbles. And how the total? Could you tell me how many marbles in this case? Huh? Okay, exactly. What's your name? Thomas, right? Okay, 25 because the total in this case is 14 plus 1, 11, so it's 25. Okay. Could you tell me how many green in this case? How many green marbles in this case? 7. Really? 7? Any other answer? Okay, Maria, please.
15,
15. So how do you get 15?
because I took 11 minus 3 to get 8. That would be the 8 small green ones, and I added them to the 7.
Okay, exactly. Maria. Okay, so I will explain the answer of Maria. So we have the box. Okay. We have the box letters. And we have here is green marble, right? And here is okay. We have a large marble, and we have the small marbles. And the last one will be 14, and the small one will be 11, right? 11. And in this case, they give us we have 7 large marble of green. Okay, 7 of green. And 3 of white. Okay. This is the picture for this. Okay, you maybe draw better. Okay, so now we have the 7 green here. So that we have the total in last marble is 14, right? So we will imply that we will have 7 whites in this one, right? And we have 3 white in 11 small marbles. So that we imply that we will have 8 green small marbles. Okay, and this is the all the information about the marbles like this. Okay, so now we have to calculate the probability of green. Okay, so now we will count green number. We will count green marbles. We have 8 green here, and we have 7 green here. So plus 7 plus 8 will be 15 greens. Okay, and now we have 15 here over 25. Is it clear this stuff, guys? Or not clear? Okay, so now the first one we need to count how many is white or how many green in this marble in this box, and after that you will know how many green in this box. Okay, and after that you will calculate the probability here. And could you tell me how many what the probabilities of the marble is small and green? Small and green. Okay, you can look at the picture like this. Could you tell me how many? What? Huh?
Is it 8?
Okay, 8. Okay, exactly 8. And 8, small and green is 8, right? 8. Okay. And the total is 25 again. Okay. And after that, you will get the result. Okay, Thomas. And the result should be 18 over 25. That's the kind of probability. Any questions about this? Okay, so now we will move on to the next one. Would you tell me describe the complement of the given events? We have 80% of 19 years old males are at least 163 pounds. Okay, so we have the complement. Wow. And the complement event here. Complement. Complement. Okay, so we have the event E. And the complement event of E will be EC. So this EC. And this means that, what is it mean? The complement event of the E is the set of all elements. That are not in E. Okay, that is the definition of this. So for example, okay, for example, I have the event is like the toys, the result of the toys is the hat, right? Something like this hat, okay, and the complement of this event is the result is not hat, okay. So that means the result is not hat, something like that. Okay, in this case, we have the event in 90% of 19 years old males are at least 163 pounds. So could you tell me what is the complement of this event? What is the complement of this event? Maria, please.
This is 20.
Okay, 20% of 19 years old males who are not at least 163 pounds, right? Okay. Okay, exactly. Okay, the answer here for is 20, okay, 20%. Okay, now we will move on to the next questions. Okay, the next question. A group fitness team classifies. Okay, so we have the information about the member here. So we have the class type two classes, member and non-member, and we have some subject here: sport, boot camp, boxing, spinning, yoga, something like that. Okay, and the question here is what is the probabilities that a class attendee is a non-member of the team? Okay, is a non-member of the team. So we will calculate how many non-member of the teams, and here how many all the members in this team. After that, you will find the probability of this. Okay, now that's easy. So could you tell me what is the probabilities that a class attendee is non-member of a team? Okay, so the first thing I want to know is how many non-member of the teams. Okay, Trivia again. 1,178. 78. Okay. So that is the value, right? You get so by you plus all the things here, right? Okay. So let me check. 1 and 666. Okay, exactly. So the first one you need to calculate the non-members, the number of non-member. So that is this guy. Okay, so that is okay. That's the right thing. So you will get the value here. Okay, and we have the totals. Okay, we have the total number is 2,184. Okay, so the probability is this number over this number. Okay, if you write like this, so you will get the wrong result. Okay, because it's not simplified. It's not simplified, so you need to simplify this formula. Okay, I think you can use the calculator to simplify this. Okay, you simplify this. If you don't want to simplify this, you will round your answer to 4 decimal places. Okay, so the answer should be 0.5394. Okay, round your answer to 4 decimal places. Okay, any questions so far? Okay, this is the question A. Okay. Okay, so now I will move on to the question 9. Before I move on to the question 9, I have to recall something about the multi-state experiment with replacement and without replacement. We have a multi-state experiment. When we talk about multi-state experiment, that means we will have the experiment. We will have 2 or more stages. Okay. For example, like the last example, like you go to the restaurant and choose the topping first, and choose the meat second, and lastly you choose the dressing. That's the multi-stage experiment. Okay. That's the multi-stage experiment. Or for example, you have a box and have the marble in this. In the first stage, you get one marble from the box, okay, and after that you will choose another one. That is multi-stage experiment. Okay, and we have 2 cases of this experiment. We have the multi-stage with replacement. and without replacement. Okay. Regarding with replacement, that means that okay, with replacement that means that we will place the object back before next state. Okay. Okay, regarding the weak replacement, for example, I have a box. Okay, where I have a box of marbles. In the first day, I get one marble from this. Okay, and after that, I put it back, and after that, I will get another one. That is called weak replacement. Okay, I have a box here. I have some marble here, some marble here. I will choose randomly one marble from this box in the first day. Okay. When I choose, I know the result. After that, I put it back, and after that, I will choose another one. That's called with replacement. Okay. And without replacement are different. We will do not place object back before next step. Okay. Okay, I have a box here, I have a marbles here. I will choose one marble from the box, and after that I put it outside. Okay, don't care about this. And after that we have five marble here, and I choose another one. Okay, and I put it outside. That is without replacement. Clear, right? Okay, that's either without replacement and with replacement. So the keyword here. So you look at the problem. A box contains 10 green marbles and 8 white marbles. If the first marble is chosen was a green marble, and the question is, what is the probability of choosing without replacement a white marble? Okay. So you go to the question 9. Question 9. So now we have the okay, 10 green marbles, right? 10 green marbles. And we have 8 white marbles. Okay, so I will choose, okay, suppose that the first marble I choose is green marble. Okay, I will choose one, I will throw it outside. Okay, I will choose one and throw it outside. So because without replacement, right? I will choose one guy and I throw it. I will not put it back in the box. So the question is, what is the probability of choosing a white marble without replacement? Okay, in this case, I will throw one green outside. So now, how many remaining marble in this box? How many remaining marble in this box, Robin, please? Exactly 17. Okay, because I threw one guy through the out of the box, so now I only have 19 remaining. So the question is probability of choosing a white marble. So we have 8 white marble in the box, right? So the probability should be 8 over the remaining marbles. 8 over 19. Clear, guys?
17.
Oh, 17, sorry. 17 remaining. Okay. 8 over 17. Okay? So when you look at the question, is you will see the keyword here is without replacement or with replacement. Okay, if with replacement, the probability is still 8 over 18. Okay, that's the difference. Any questions so far about this? Okay, we will go to the next. Okay, now we will go to the conditional probability. Okay, Can you see the screen? You see, right? Okay, it's far away maybe. Okay. So now we will erase this. We go to the conditional probability. So the conditional probability, I will give you the formula for this. Okay, we have the probability of f given e. Okay, we will read is probability of f given e. Of the event f given e. Okay. So the probability of this one will be probability of e and f over probability of e. That is the conditional probability. Okay. And now we will look at the problem for this. Okay, it's different. It's different problem. Okay, I will do another one. Okay, here. Okay, at 12. Okay, move on to the example 12. Okay. For example, we have 421 applicants for a job. Okay, and 128 have over 5 years experience, and 57 have over 5 years of experience and have a graduate degree. The question one is, what is the probabilities that a randomly chosen applicant has a graduate degree, given that they have over 5 years of experience? Okay, here is the conditional probabilities, right? Conditional probability. So I will get you the problem. We have the probability. We need to calculate the probabilities applicant have a graduate degree. With the condition that they have 5 years experience. Okay, that's the question we need to calculate, right? Okay. So it's equal to probabilities of the applicant have a graduate degree and 5 years experience. Over to the probability of applicant have 5 year experience. Is it clear in this step, guys? Okay, just apply the probability, conditional probability. Probability of applicant have a graduate degree, given that they have 5 years experience, is equal to this one. Okay, we need to calculate the probability of applicant have a graduate degree and 5 years experience over to probability of applicant have 5 years experience. Okay, so we need to find this probability and find this probability. Okay, so could you tell me what is the probability of applicant have both? Okay, have a graduate degree and 5 years experience. Okay, drop in again. 57. Okay, exactly. 57 over the total number of applicants, right?
Yeah.
Okay. So it's equal to so I will write down here. It's equal to this guy. Okay, I will write down here. Over to the total number of applicants. Okay. And what about the probabilities of the applicant have 5 years experience? So we need to calculate how many number of applicants have 5 years experience. Okay, Trevor.
128.
Yeah, exactly. 128 over to this number. Okay. So now you will get the result here is, okay, divide to this guy. So you will get the result here is this. Okay. So the final answer is this number, or you simplify it. You can write in the decimal place, 5 decimal places. Any questions so far about this? Okay. Okay, I will give you the answer for step 2. Step 2. Step 2. Okay. So they ask you what consider that 161 of the applicant have a graduate degree. So the question is, what the probabilities that an applicant has over 5 years of experience with the condition that the applicant have a graduate degree. So now we need to calculate the probabilities of the have 5 years experience, right? 5 years experience. Given that they have graduate degree. So the answer is the probabilities. Okay, using the formula you have is 5 years plus, okay, and graduate degree, have graduate degree, over the probabilities of the applicant have graduate degree. So could you tell me, okay, probability of applicant having 5 years and graduate degree? Okay, it's similar, right? Okay, we have, okay, it's 57 over the total number of applicants. Okay, and probability of graduate degree. Okay, so we have the information here. We have the 161 applicants have graduate degree. So it's 161,421. So it's equal to this value. Okay, clear, right? Any questions so far about this? Okay, so I think we stop here, and next Wednesday I will review more things about combination, perturbation, random variables, expected value.